Okay, welcome back to another exciting installment of probability. We're going to keep talking about compound probability today. All right, let's think about this problem right here. So in the last lesson, we talked about different ways you can keep organized, making lists, tables, tree diagrams to figure out compound probability. So if I had this problem here where I have to draw a card, put it back, and then pick another card, I could use a list to figure out all the possible outcomes. Like I could get a 2 and a 2, 2 and a 3, a 2 and a 4, a 2 and a 5. I could get a 3 and then a 2, 3 and a 3, a 3, 4, 3 and a 5, 4 and a 2, 4 and a 3, a 4 and a 4, and a 5, 5 and a 2, 5 and a 3, 5 and a 4, a 5 and a 5. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different things that could happen in that situation. So I have 16 outcomes. All right, but what if I didn't need to know what each specific combination was, but I still wanted to know how many possible outcomes there were? Is there an easy way? Yes, there is. Go ahead and pause the video and copy this down. Okay, so our fast and easy way is to simply multiply the number of outcomes for each event together. So in this example here, it says how many sandwich combinations can be made with 2 types of bread. Oh, where'd my pen go? 2 types of bread, 3 types of cheese, and 4 types of meat. Well, all I need to do is go 2 times 3 times 4, and then that gives me 24 outcomes. I can make 24 different types of sandwiches with those combinations. So hold on, I'm going to take it back to this problem here. So how many different types of, or how many outcomes are there for each event? Well, the first time I reach and I pull a card, there's 4 different cards I could pick. And if I reach again and I pull another card, there is still 4 different types of cards I could get. So 4 times 4 is 16. 16 possible outcomes. And if I look back to when I solved it the old-fashioned way, look, I got myself 16 outcomes. Okay, go ahead and pause the video and try this on your scratch paper. Remember to write down any questions you have as well. Okay, there's another shortcut that you're going to like that can help you figure out probability without doing a table, a list, or a tree. Now, sometimes you do need to know every single possible outcome, but sometimes you don't. And so this is where this trick comes in handy. So if I want to know, hey, what's the outcome of rolling 2 dice and getting a 2 and a 3, I can just simply consider, hey, what's the probability of getting a 3 on this die? Ooh, lucky me. There's 1 3 out of 6 sides. And what's the probability of rolling a 2 on this die? Okay. There's 1 2 out of 6 sides. And so what's the probability of rolling a 3 and rolling a 2? Well, I would just multiply those two probabilities. I'd get 1 6 times 1 6. And when you multiply fractions, you just multiply across. So 1 times 1 is 1. 6 times 6, 36. So I have a 1 in 36 chance of rolling a 3 on the first die and then rolling a 2 on the second die. Nope, still hasn't happened. Okay, go ahead and pause, write all this down. All right, so our fraction method, instead of the table, the list, or the tree, because sometimes we don't need all that, is to find the probability of each event and then multiply them together. So if I think about rolling a die here, the probability of rolling a 4 is 1 out of 6. Probability of rolling a 1 is 1 out of 6. And I multiply across and I get 1, multiply across and I get 36. I have a 1 in 36 chance of this happening. Now, what's my probability of getting a 2 and a 2? Well, probability of getting a 2 is 1 6. Probability of getting a 2 is still 1 6. Dice does not remember what happened last time, or one dice doesn't know what happened with the other dice either. So look at that. My odds are still 1 in 36. of getting a 2 and a 2, just like it was for getting a 4 and a 1. Okay? What's the probability of rolling a 3 and a number greater than 3? Well, probability of rolling a 3, there's a 1 in 6 chance. One side's a 3 out of 6 sides. And I'm going to multiply that by the probability of a number greater than 3. Greater means bigger, so 4, 5, and 6 are greater than 3. So I can write this as 3/6, or I could write it as 1/2 as well. So if I write it as 3/6, I'm going to get 3 over 36, which I would need to simplify and get 1/12. If I write it as 1/2 in the first place, it'll automatically take me right to 1/12 as my answer. All right, give this a try on your scratch paper. What's the probability of spinning a blue and then spinning a red? Okay, one more situation. What about a problem like this? So I'm going to pick a card at random, but now I'm not going to put it back. And then I'm going to pick a second card at random. So for example, if I pulled a 9, when I reached to go pull another card, the 9 would not be there anymore. So this is a slightly different situation than what we were talking about before. This is called a dependent event because the probability of the second event depends on whatever happened the first time. Like if I go to reach in again, the probability of what's there depends on what happened the first time, which was taking a card out of the deck. So now my situation has changed a little bit. That's a dependent event. Go ahead and pause, copy this down. Here's an example, pulling a card and not putting it back. That's an example of a dependent event. Okay, so here it is again. What's the probability of picking an even number and then picking an odd number? And I'm not going to put it back. So a little alarm is going off in my head that this is a dependent event. So the steps are still the same. I'm finding the probabilities and multiplying them together, but I'm remembering that I'm not putting that first card back. So what's the probability of picking an even number and then picking an odd number? Okay. Probability of an even right now is there's 2 evens out of 4 cards. So that is 2/4 or 1/2. Okay. So I'm going to multiply that by the probability of getting an odd. Now wait a second. One of my even numbers is gone. It doesn't really matter if it's the 6 gone or the 8. Okay. How many cards do I have left? Now I only have 3 cards left, so my bottom number is going to be 3. Again, if you don't like me simplifying, I'll just keep it up there. Same thing. So now how many odds do I have? Well, that's an odd, that's an odd. So I have a 2 out of 3 chance of pulling an odd number now. So I'll go with my nice simplified one down here, and I would get 2/6 is my answer, which simplifies down to 1/3. Or if you kept it like this here, you would get 4 out of 12, which still simplifies down to 1/3. So I have a 1/3 chance of pulling an even, keeping it, and then pulling an odd. Okay, go ahead and pause and copy this down. A bag has 3 blues, 2 reds, and 5 green marbles in it. After pulling a marble, it is not put back. I'm not going to put it back. Okay? All right. So what is the probability of getting a blue? Well, there is 3 blues out of how many marbles? How do I figure that out? I just need to add all my marbles together. Okay, 3 plus 2 plus 5 is 10. So my probability of blue is 3/10. Okay? Now I have one of the blue marbles in my hand. I'm not putting it back. Okay? So now there's not 10 marbles in the bag anymore. Now there are 9 marbles in the bag. And how many of those marbles are green? Well, 5 of them are green. And if I multiply that together, and again, you can do the whole cross-canceling thing, remember? Make life easier so you don't have to simplify later on. Like that. I would get a 1 in 6 chance. Okay, I'm actually going to rewrite it pretty up here, and you are too, my pretties, because that way I want you to be able to read what we originally put. Okay, all right, now we're going to put our marbles back in the bag, take them around. What's the probability of getting a red, keeping it in our hand, and then reaching in and pulling another red? Well, Probability of the first red, there's 2 reds out of 10 total marbles. But now I'm going to keep one of the reds in my hand. So now how many reds are left in the bag? Only 1. And now there's only 9 marbles left. And I go ahead and I'm going to get 2 out of 90, which simplifies to 1 out of 45. Only 1 in 45 chance of pulling a red and then another red if I don't put that first one back. All right, last one. Go ahead and pause. Try this first problem here. And remember, you are not putting the first card back. I will see you tomorrow with your notes, your 3 problems on your scratch paper, and any questions you have for me. Bye.